Okay, let's have a look at example 5. So it says at a coach station, the maximum temperature in degrees C and the number of bottles of water sold were recorded over 10 consecutive days. The collected data is summarized in the table. So you've got the table. I'm not going to insult you by making you sit and watch how I input this into lists and spreadsheets. And it does say plot the data points on a scatter diagram. So it's anticipated that you will probably draw this using graph paper, etc. But for example's sake, we're going to use the GDC. It then says comment on the correlation, find the equation and the regression line of y on x, which is our standard regression line. Draw the regression line on the scatter diagram. The temperature is predicted to be blah, blah, blah. Okay, so we'll deal with that in a second. So if you pause the video, you'll be able to input your data, or you can watch the video and then have a go at it. So the first thing we're going to do is we're going to use common sense. Okay, so what do we anticipate to see? If the temperature goes up, we would expect what? More bottles to be sold, more water to be sold. So we're expecting some sort of positive correlation. Okay, so let's put this into a data and statistics. We're going to put it on the table. We're going to say that the temperature is the independent variable and the number of bottles sold is the dependent variable. And surprise, surprise, it appears that as the temperature increases, the number of bottles sold increases. So comment on the correlation. Visually, it's positive, okay? But if we go back here, what we can do is we can say, right, well, let's ensure that it's positive. So if we go to menu, statistics, stat calc, two variable statistics, or we could even do linear regression. In fact, let's just do linear regression mx plus b. The x data is our temperature, our dependent variable is our number of bottles, and the first, we want our information being put in C column. Okay, so the reason that I've chosen to do this is when we look at the question C, it says find the equation of the regression. We have done that now. So we've got the gradient is 8.05 and the y-intercept is negative 24.7. But we also get this r squared value here, the coefficient of determination, which tells us we've got strong, and we've got the r value of 0.931, which is very close to 1. So that's telling us we've got strong positive correlation, and now we've got the values to back that up. Find the equation, so it's y equals 8.05 x minus 24.7. There's your equation regression line. And then if we go back here, what we can do is if we go to menu, analyze, regression, show linear, we have those values again. Okay, so that is the regression line for y on x. We've got y equals 8.05x minus 24.7. So I've just had to make a note of those because it says in E, the temperature is predicted to be 19.5 degrees. Estimate how many bottles of water should be stocked according to this regression line. So sadly, we can't input the data and we can't eyeball it either because our scale, so 19.2, 19.3, 19, no, so round about here somewhere, if we go up, we can't really eyeball these values. So what we're going to have to do is we're going to have to add a calculator. And what we're going to do is we're going to type in 8.05, which is the gradient. We're going to times that by the temperature, which is 19.5, or our x value. Then we're going to take away 24.7. So our estimated number of bottles to be sold is 132. Okay, so we can use our GDC for all of that. Draw the regression line. We should be accurate. If you are plotting, your accuracy is plus or minus half a square.